Hey guys, thanks for tuning into CMTEQ channel. This is stm32 programming. So this is part 2 of the previous tutorial where we were coding a binary counter. So if you are finding this tutorial helpful, please just assist by giving it a thumbs up and also subscribing to my channel if you want to see more tutorial like this. So now we are continuing. So the next state is either one of these buttons is pressed. So let's start by the up counter, so which means we're going to put another if statement here. So if, right, then we need a condition. So if this button is then pressed, so in order to get this button pressed, we also need to get a pin reading. So we're going to read if it is equal to 1. So this expression is basically just writing it like that without negating it. It's the same thing, and it is also the same thing writing it is equal to 1. If we write it equal to 0, this is the same thing as negating it like that. So it is the same statement. So this here means if button up is 1, that means it is pressed, because as I've already said, the button is internally pulled down into the IC. So when we press it here, I'm pulling it high to this red probe here, which is a 5 volt. Okay, so when I pull it high, then it will read a 1. So if it read a 1 and the previous one still read a 0, right? So I'm going to copy that because this is an AND gate. So with both conditions must be true, right? So if this button is reading 1 and this button is reading 0, that means it's still not being pressed. Then we need to start counting up, right? So in order for us to start counting up, what do we need to do? Now, in order for us to start counting up, we need to get a conditions and only execute a shifting of the bit, because we're going to start using the right pin function to start toggling pin by pin, okay, as we are moving to a full 5 pins being toggled to 1. Now the countdown value here that's specified to be equal to 31, that is a value that we're going to reach when we count up, so that when we reach the count up value of 31, then we stop counting up, then we start over. So we're going to use that value. So we're going to use it inside the if statement. So I'm going to use another if statement, okay? So in this if statement, just to open the bracket there, in this if statement, I'm going to say, well, if count up is less than 31, right? Because we are counting up. Remember, we already initialized the count up to be equal to 0, so which means we know that it is equal to 0, so this statement is true. Okay, so if it is less than 31, which make this statement true because count up is 0, then we need to execute something. So we need to start shifting our bit. Okay, now consider this here as your 16-bit register from the GPIOA, right? Now these 4 bits here, the 5 bits here, are where our LEDs are connected. Okay, so what we're going to do is we're going to play with them. So in order for us to start writing here, we need to shift, because we need to jump P, A, 0 and 3. So this is why we're shifting by 4. So we're going to shift by 4, 1, 2, 3, 4 bits here. So we're going to do left shift by 4 and we start writing here. So once we get here, the first time we come, we're going to write 0. And then we're going to get out, we're going to delay. We're going to delay. After delaying, then we're going to increment the count to be 1. Okay? Then we come back. We set everything back to 0 again. And this time we're going to write 1. We write 1. And we are going to still be shifting by 4. Left shift. Then we write 1. We comes out. Okay, we comes out, we delay, and we increment the counter to be equal to 2. We come back, we reset them again to 0, right? We reset them again to 0. And then when we come back to write, we are now writing 2 because the counter value have been incremented to 2. So we're going to now write 2. So once we write 2, since we are left shifting here by 4, then we start writing here. So to write 2, then we're going to write 1 here, and then 0 going to be there, and that's going to result to 2. Then we come back again, right, after clearing everything, and then we come back, but the clearing is going to happen very fast. You're not going to see it. So when we come back again, this time around, the bit have been incremented to 3. So start writing 3 from here. That means we're going to have 1, and we're going to have another 1. That will result in 3 in decimal counter, all the way until we're going to get to write all of them to be the full 31. Once they all 31, once they all been written to 1, 1 and 31, then the condition is going to be false. When the condition is false, then we exit the loop. So this is what we're going to manipulate this register. So to do that, let me get into my if statement, and I'm going to then call the HAL GPIO library to write a pin. So I'm gonna just copy it. Okay, so I copy HAL GPIO write pin GPIOA. Now the first thing we're doing here is we're going to reset them to 0. So we're going to write a low, right? Just as I was explaining there, we're writing everything low. As soon as we finish writing everything low, we then come back, we do another write just after resetting them, and this time around we're now going to write a high. We're now going to write a high, but where are we writing a high? We're writing a high in a specific location. The specific location is we are shifting by 4 to the left. So we're jumping, like I've said, we're jumping PA 0 and up to 3. So we're starting to write by PA 4. And what are we writing there? We're going to write a value of count up. Since count up was already 0 there, that is exactly what we're going to write. So what I'm going to write here is count up left shift by 4. So we left shifting by 4, and we're writing the value of count up, which is 0 in this case. And then we done writing, so everything is gonna be just off the first time. Then we delay. Okay, so we're just going to put a delay here. After delaying, we come out of the delay, then we increment the count up variable. We increment the count up variable, then we get out. We come back again, we check the condition. Well, the condition is still true. Since the condition is still true, then we come back, we reset again everything. So we're turning everything for, basically we're just clearing everything we just wrote. And then we come back, this time around, count up is now 1. So we're starting to write again on the 4th bit there, on the 5th bit, PA4, and we write 1, the new value of count up, all the way until this condition is going to be false. That is the time when we will be having the full 31 bit written from that register location. Right now, what is going to happen here when this condition become false? This condition become false, that means we no longer going to execute this code here, okay, but this condition is still true. Then this is where we're going to call an else. So we're gonna say else. Else what? Well, else we're going to reset the count up value. So we're gonna reset count up. Why are we resetting count up to be equal to 0? So that this condition is going to become true again, and then we start over again, right? And then we can delay after resetting the count up. This time around we can just set the delay for 100,000 there. And these will create a situation where we're just going to be circling. And one more condition I want to add that will now be outside this else statement here is to reset the j to be equal to 0. So that, okay, so that this condition also that became false after j was no longer less than 2 can become true again, so that when we exit here, we can still flash this twice. Now, let's write this into our board and see if we are indeed executing the right things in there. Compile. Oops. What is happening here? No, we cannot proceed. There are errors. Where are the errors? Okay, declaration function. Okay, that one does not exist. The delay does not exist there. Okay, well, I think that's the only fault that is there. Let me just first build before we load it in. Okay, no error this time around. Now the code is now going to build to run, load into the chip. Okay, so we can see, you see this table here is very important. It tells you how much flash memory you already use, so it is important. So far it's just 3% only, so we can write a lot of code for this specific chip here. All right, okay, so we are getting through. There we go. So it flashed. That means the program has been loaded. Okay, cool. So now let's test. Okay, first I'm just going to press here. Okay, that part is still working. Now I'm gonna start with the up counter. Okay, there we go. There we go, it's counting. There we go, it's counting. It's counting. As you can see, we are actually going up. Now I stop, it does flash. You see, I stop the count, it flash once and then it goes out again. Now I can start again. You see, now it's not resetting. The count is not resetting to 0. So right now, look at what's the value there. There is a value that is written there. I release, it flash, okay, into the first condition. And when I press again, then we pick up the count where we left off. Now this is a condition that you can solve if you want to. But if you want a counter to reset to 0, then you need to load in the value in which you are counting down so that it can reload it and then start over again. But let's just see that we are actually counting up to 31. So let's go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31. Now you can see we are not seeing the full 31, it's going down, okay? Because as soon as it's reaching that 31 bit and then it goes down. So in order for us to actually get the full 31, we need to just increment this to 32 so that it's going to display the 31, but we won't see the 32nd bits being written, right? Okay, so now we can go ahead and do the down counter, since we are now completed with the up counter and it is working and it's flashing when we release it because we're coming into this first condition here. So we need another else if statement. This one should actually be an else if, because this is an if statement and that's an else if. Then we're going to copy this code here. We're going to copy this code and create another else if statement. This is what you call an else if ladder. So now in this third statement, we're now going to check the condition in which this button is not being pressed. So it is pulled down internally and this is now being pressed and it's pulled high. So the trick here is just to change this become a 0 and this become a 1. Okay, so in this condition, when this button is being pressed, what you are going to do, we're going to count down. We're going to count down from the preloaded value of countdown. So the countdown preloaded value here, where is it? It's 0x1f, right? So we now going to replace this to count down. Now we need to count down from 1f, which is 31. So the condition will be if countdown, right? If countdown is greater than 0. So remember the countdown variable value is 1f, already set, initialized to 31. So if that value is less than 0, then we're going to execute this code. We're going to set everything off. That is our reset. Quickly after setting everything off, and we're going to write a high. Now what are we writing a high? We're going to write a high the value of countdown. So the value of countdown, we know that it is this value here, 31. So we're going to shift left again 4 digit, right? We're going to shift 4 bits to the left and we write 31. So when we shift 4 bit to the left, we start from here, we write 31. It will result in us populating 1111 into all these pin 5 and we get 31. And after doing that, we then going to delay, right? We're going to delay and we're going to decrement the countdown value. In this case, we then going to decrement the countdown value. So after we decrement it, it's no longer 31. It's now going to be what? It's going to be 30. Okay, so that means we are removing this one here, a 0, then we're writing 30. So what is going to happen is we flash and we write again 30. We delay, we decrement, we come back, we flash, we write the new value. Just like that until this condition is going to be false. The same way we've done up there. Okay, now what happened when we reach 0? Okay, when we reach 0, well, we're going to reset the countdown variable. So we're going to reset it to its value. So I'm just going to copy now this value here and write it here. So we're just going to paste it there. So we're resetting the countdown variable and we delay and we start over again. And we have our variable for resetting the initial condition there as well. Okay, so I'm sure if we can write this program in, there is not going to be an issue. Let's build it first. Okay, build complete, no errors. Now we need to load the program. Okay, something is happening. Okay, so the program has been loaded. Now let's check the initial condition. That condition is working, and this condition is still working. Okay, we're still going to be counting up. Okay, so no problem. And then let's try again now the countdown. So when I hit this, you can see all the LEDs become illuminated and I started counting down. When I release it, I'm getting the flash. That means I'm coming into the first if condition there. Now let's just count down. Okay, so you can see that it's not resetting to 0. So that is something we just need to fix it. But it is indeed counting down. As you can see, we're counting down. You can see we're counting down. That's 7, 5, 3, 2, 1, 0, and we start again. Okay, so this is basically working, and now we can go ahead and check for the other condition. So the other condition is, let's say when both are pressed, right? So when I press both like this, something should happen. Okay, so if I press both, something should happen, but now there is no condition to handle that, so there is a confusion. So this one say, hey, is it a countdown or a count up, or what is going on? Nobody knows. So we need a condition to handle that so that we can avoid our code from putting our code into a position of stalemate. Okay, to achieve that, I'm just going to come down here. This time it's no longer an else if, it's just an else because this is now the last condition. So I'll open my bracket and now I'm inside here in my else, and what am I going to do? I'm going to then reset everything. Okay, so I'm gonna say count up is now equal to 0. Whatever the value of count up was, we set it to 0, and then we also take the value of count down variable. Okay, count down variable, and we also going to reset that one to the value in which we were basically counting down, which is 1F hexadecimal. That is equal to 31 in decimal. Right, after initializing our two counters, we can then go ahead and open another if statement. And in this if statement, we now need to check the condition in which both buttons are being pressed. Now, both buttons are being pressed does not exist in these two conditions, because right now we are taking care of the condition in which no buttons is being pressed, and we're taking the condition in which this one is being pressed and also this one being pressed. So they've been taken care of. We don't have the condition in which both buttons are being pressed, so which means if we do an else, it will automatically fall into the condition in which both buttons are being pressed. That's where the else will apply. So we then don't have to specify whether the buttons is what equal to 1. So we leave it just like that. Great. So we need now the condition. What are we going to do when the two buttons are being pressed? What are we going to do? This is where we need this if statement. Remember, I said in the beginning here, you can basically do whatever you want to do. But in my case here, I want to start counting in a multiple of 2. So I'm going to start counting 1, 2, 4, 8, displaying it into this binary digit here. And once it roll out, I start again over. So in doing that, I'm going to create a variable. Okay, I'm going to create a variable and I'm going to call that variable sequence. So I'm going to come up here and declare another variable, unsigned integer sequence val is equal to 4. Why 4? Because we also going to do a shift, right? We're going to do a left shift in with this sequence val. This is why we are starting in by 4, because we know that our LEDs, they're starting here by the 5th one. Okay, so which means we need to shift by 4 and then we start writing our value. So when we shift sequence by 4, and we're going to start by writing 1. So we write 1. So this is now assuming everything here is 0. Everything is 0, we write 1, and we increment this value after writing 1. We increment this value, okay, and we shift again by 4. So after writing 1 here on the first slot, we then come back, we increment the shift variable by 1. So this time around, we are no longer shifting by 4, we are shifting by 5. After clearing as well, then we're going to come here and then we're going to write 1 here, and this is now going to be a 0. And we're going to have a representation of 2. And then we're going to go again. We're going to then clear this bit again, and we're going to increment a shift variable again by 1. Since we started by 4, the first increment is going to be 5. The second increment is going to be right here. So we're then going to write a 1 day, and that's going to result by writing a 4 day. And then we're going to clear it again, and we're going to increment again, and we're going to write a 1 day, and that's going to result by 8. So in my if statement, I'm going to say if sequence val is less than 9. Why less than 9? Because we're going to start incrementing by 4, and we're going to increment 5 times. Okay, so by the time we get to the 4th one, this condition is now going to be false, and we're going to exit the loop, and we start over again. So once this so long as this condition is going to be true, which is true for the first case, second case, third case, and after the 5th increment, and then it's going to be false, then we're going to do something. What we're going to do is basically what we've been doing here. So I'm just going to copy this, because we've been setting bits with the right pin function. So I'm going to use this just to reset again to low, and then I will come here. Now here the business is going to change. This is now the guy that we're going to be incrementing. Remember, when we were counting down or up, we've been incrementing the value or decrementing the value. Now I'm going to be playing with the left shift value. So this is going to remain the same. So it could be either we are just writing a 1, but in programming term, we're going to write a 1 unsigned long value. So we're going to write 1 UL, and we will be shifting it by the value of the sequence variable. So that will be sequence val there. So we're gonna use the value of sequence val as a shift, and we're shifting and then writing a 1. We're shifting by the value and writing a 1. So we shift by 5 and then we write a 1. We shift by 6 and then we write a 1. We shift by 8 and we shift by 9 and then we write a 1. Okay, and after shifting, then we got a delay. So I can just copy the delay and paste my delay there, right? And the next thing is basically to just increment my sequence variable. So I'm going to then increment my sequence variable like that. Okay, so this condition will create that switching one of these LED one at a time. Not all of them, but I'm going to be counting by multiple of 2. So I will go 2, 4, 8, and 16. Correct. Then after here, then what? Then it's an else, right? It's an else, and inside the else condition, you can just basically reset your sequence to be equal to 4 again, because you are resetting it to be equal to 4 because you want this condition to become true again. Because after incrementing it 5 times, this condition is going to be now false. So you have to reset it in order to continue. That way, if both buttons are being pressed, then you're going to continuously be inside the sequence loop. Okay? And then you can then reset again, once again, J to be equal to 0. Okay. Now, we are good to go. So I'm going to build it again. And we can write the program in. Okay, now we are ready to test again our program. Okay, cool. So let's go straight into our sequence. So I'm going to now press both buttons and then we're going to see what's going to happen here. There we go. You see? We are counting. So we start 1, 2, 4, 8, 16. We start again 1, 2, 4, 8, 16. Now it seems that it is very much slow, so we want to make it a bit faster. So I'm going to decrease this delay. Well, we can write the program in again and then see what's going to happen. Just test it again. All right, okay, so we are ready again here. Okay, now let me press the 2 buttons and see what is happening. Okay, you can see now it's going quite very fast. It's like a good sequence, a siren. We basically counting 1, 2, 4, 8, 16, 1, 2, 4, 8, 16, 1, 2, 4, 8, 16, and then resetting, going all over because we are resetting here. Once this condition is becoming false, we are resetting here. Now, when I'm counting down, we are counting down. If I release, okay, and I start counting again, it is starting from where I left off. Now, in order to reset the counter, we have to press the reset button. So if I reset and then I start again, I'm going to start from scratch. And the same will apply if I'm counting up. So I'm counting up, I release the button, and then I press again, I start from where I left off. If I want to start the counter, and then I press the reset button, then it's going to reset the counter from scratch. Now, if you don't want to reset the counter with a reset button, all you have to do is basically to take the count up value, that is 0. You then need to just write it up here where you are starting to count down. So basically, you must just take this. Okay, if you take this and you write it there, and you take the countdown variable, this variable here, and you must just write it where you are starting to count down. Okay, so that basically here where you're starting to count down, and the count up, you must put it here where you're starting to count down, like that. So if you write it like that, that way you will be able to reset the count when you move to the next one. So if I was counting on this one and I start counting here, I'm resetting that countdown value and vice versa. So this is basically it, guys. Thanks for watching. If you've learned something in this tutorial, please don't forget to subscribe to CMTEQ channel and give this tutorial a thumbs up. That will be highly appreciated. Stay tuned for more STM32 programming tutorial in the coming days. Until next time, cheers.